In the last video, we talked about typical male and typical female external genitalia and gonads. In this video, I want to talk about the intermediate. Remember, we were talking about variation in sexual dimorphism, well, talking about sexual dimorphism, and that male and female, our language, English uses these two discrete words as if this is a completely binary situation, but actually there's so many different factors that influence the development of sex, male and female, and it's so multifactorial that we actually end up with this category in between. You end up with overlap between the variation in male and the variation in female. There's overlap, and this overlap is called intersex. But intersex is a lot of different things, and in this video I want to spend some time talking about what intersex looks like, some examples of that to get a sense of that variation and what that overlap between male and female, what it looks like. Let's get some vocabulary down. Androgyny means an individual who has both masculine and feminine characteristics. Transgender is gender identity different from biological sex. And intersex is an individual who has gonads that contain both ovarian and testicular tissue and ambiguous genitalia. And one of the important things to keep in mind is that language changes and evolves and grows, and if you are not a member of the LGBTQI community, but you'd like to demonstrate your respect for these people, the people who do identify in that community, a great way to show your respect is to use the terms that people in that community are comfortable with. So a great resource is to actually go to glad.org, and there you can kind of follow how the language is evolving, and a really good way to refer to people who do identify within that community. So you've seen this already, so you have a good sense of the early development of the gonads and the genitalia, and how complex this is, and how many genes are involved, how many different proteins and hormones. You also know that up to week 6 of embryonic development that it's all the same, and it isn't until the SRY gene kicks in, starts to be expressed, SRY gene on the Y chromosome, that you then have this deviation from the standard development, a deviation that goes into this more masculine, a masculinized developmental process. So one of the things that happens, I want to go a little bit more specific into what's happening at that gonadal level. So here we've talked about the genitalia. So let's talk about gonads. They're actually in that embryo at 6 weeks and leading up to 6 weeks. There's actually 2 different ducts. There's the female duct and the male duct, and all embryos have both. So all embryos have that ability to form male or female gonads. So the female duct is called the Mullerian duct, and the male duct is called the Wolffian duct. So what happened is when the SRY gene turns on, is that it leads to a cascade of events that starts the maturation of the testes. And as the testes start to mature, they release a substance called the Mullerian inhibiting substance, and MIS. And when MIS is expressed, what happens then is the Mullerian duct starts to be resorbed. In the absence of MIS, so when there is not MIS being expressed in the embryo, the opposite happens. The Wolffian duct starts to will mature. It starts to mature, and the Mullerian duct starts to mature, and the Wolffian duct is the one that resorbs. And so the real critical thing here is what happens when that Mullerian inhibiting substance is released. So that's how you end up with those differences between the ovaries or the gonads and the testes and the structures that go with those. And you can see them sketched out here in the illustrations. So the testes starts to release that Mullerian inhibiting substance, MIS. Testes also release, they form different kinds of androgens, and there's lots of different androgens. Testosterone and estrogen are androgens, so the ovaries also make androgens. The testes make a lot more of these androgens than the female ovaries do, but both types of bodies make androgens. So one type of androgen that is important in that early embryonic development, that early masculinization of the gonads, is DHT, or the dihydrotestosterone, DHT. And I bring up DHT because I want to share with you an interesting phenomena that demonstrates how complex this whole process is and how easy it is to perturb it. So I want to give you to tell you a bit about the juevedoches. This is a nice example of gender fluidity. In the 1970s, Western medical doctors started noticing an increased number of, or started noticing that there was this group of individuals in this small town in the Dominican Republic that were actually called by a different term. And so there were boys and girls, and then there were the juevedoches. Forgive my horrible pronunciation. So what was going on, what scientists have figured out is happening here, is that there is a high frequency of individuals that are born without this 5-alpha reductase so they have a deficiency in the 5-alpha reductase. So in this gene that's really important in the production of DHT, so that androgen that I just mentioned in the previous slide. So it's an autosomal recessive trait, but when an individual who has X and Y chromosomes, who has a genetic sex of male, when they have 2 copies of this recessive allele, their bodies don't make DHT, which then means that they don't have testes descent during embryonic development before birth, and they don't form all of that more masculinized anatomy or external genitalia. But when these people get to puberty at around age 12, the testosterone that is produced, the really increased level, sorry about all my text messages, the really increased level of testosterone production compensates for that DHT. My goodness. Makes up for that reduced level of DHT earlier in development, and all of the adult male features start to appear. And so the penis enlarges, the testes descend, and all of the male genitalia are present. And so people in this village, in this town, were like, hey, we need a third category. So we have boys and we have girls, and we have the juevedoches. And it's a really neat example of how language can accommodate these intersex categories and work with the biological variation. These individuals aren't, they don't stay intersex. They often identify then as men after they go through puberty. So they may or may not have identified as girls or been comfortable with that identification of girls. But then after puberty, they generally identify as men. So you have this fluidity going on. There's many other mechanisms through which you get to this variation, and I wanted to give you some examples, just a few more examples to give you a sense of this variation. Because remember, these processes are not on-off switches. There are a lot of sources of variation. So we've talked before about Klinefelter syndrome, where people are XXY. So because they have a Y chromosome, they have the SRY gene, and so they have that masculinization. But because they have two X chromosomes, there are also some more feminized aspects of their phenotype. About 1 in 500 to 1 in 1,000 males have Klinefelter. Many of them never know that they have this. As I mentioned before, they have sparser body hair. They might have some breast tissue, maybe not enough to sort of be noticeable as outside the range of variation of what you see in sort of that stereotypical male anatomy. They do have somewhat wider hips. Their voice might not be quite as deep. They're normal sexual function, but they do often have fertility issues because they have lower sperm counts. Then you have congenital adrenal hyperplasia is another example. This is an autosomal recessive trait that affects the adrenal glands, which leads to this inability to make certain enzymes. And because they can't make those certain enzymes, they actually have this increased production of androgens. And so you also then have this androgen insensitivity syndrome. So you can either have kind of too many androgens circulating in the body, which would lead to a more masculinized body for a female sex determination. So if you have XX but congenital adrenal hyperplasia, you're going to have more androgens and a more masculinized anatomy. Then you have androgen insensitivity syndrome, and in AIS, an XY person is actually resistant to androgens. And again, androgens are the hormones that are elevated in males. So these people will have all of the physical traits of a woman, but genetically, they are XY. This is actually a allele, a mutation that happens on the X chromosome, and it affects about 1 in 20,000 live births. So incomplete AIS can lead to male infertility. So there's kind of a range of variation in AIS going on as well. Okay, then there is gonadal dysgenesis, and this is a term that is used for just anything that disrupts the development of the gonads and the derivation of the secondary sex characteristics. And this is when hormones just aren't really expressed to the degree that they are in other bodies. And what happens in these individuals is they tend to have the phenotype of a young girl, because remember, that's the default for human bodies. Let's talk about some demographics to give you a sense of how common these are. So Klinefelter, as we've discussed, affects about 1 in 500 births. Androgen insensitivity syndrome is 1 in about 13,000 births. Partial androgen insensitivity syndrome, 1 in about 130,000 births. Classical congenital adrenal hyperplasia, 1 in about 13,000. Late onset adrenal hyperplasia, 1 in about 66 individuals, much more common. Vaginal agenesis, 1 in 6,000 births, so just not having a vagina that formed. Ovitestes, where you have a combination of tissues, of gonadal tissues, affects about 1 in 83,000 births. There can be what we call idiopathic effects. This is when there's no discernible medical cause, but just random things that can happen during development that disrupt the more typical anatomies. This affects 1 in about 110,000 births. There is complete gonadal dysgenesis in about 1 in 150,000 births. Hypospadias, remember when we were talking about male anatomy and the development of the penis, that urethra is encompassed in the shaft of the penis, and that it doesn't always get fully encompassed where the opening of the urethra is at the glands of the penis. So hypospadias is a set of conditions where that didn't completely happen, where the urethra doesn't open at the tip of the glands of the penis, but rather it opens in the perineum, so way farther down, or along that penile shaft. And this is about 1 in 2,000 births. There is also hypospadias where it's sort of much less severe, and this happens, so that's happening much higher up between the corona and the tip glands of the penis, so it's much closer to where it is in typical male development. That happens in 1 in 770 births, so it's actually quite common. Let me give you some more demographics. So a sex differentiation specialist is called in to help categorize 1 in every 1,500 babies born in North America. So that means that out of every 1,500 babies born, the nurses and the doctor that delivered the baby, they look at the baby and they're like, it's ambiguous, I'm not sure actually, and they call in a specialist. 1 in 500 babies, actually a little more than 1 in 500 babies born is not XX or XY. 1 in 100 babies born has a body that is different from these standard ideas of male and female anatomy. So to give you a sense of how common this is, my daughter was born at Alta Bates here in Berkeley, and the year that she was born at Alta Bates Hospital in Berkeley, there were about 10,000 other babies born in that same hospital. So statistically speaking, about 100 of those babies are intersex. So intersex is a social identity that attempts to capture this diversity, that variation in sexual anatomy, in sex chromosomal composition, in gonadal, in genitalia development. So there's a whole suite of factors that lead into that variation. And intersex is a category that gives a social identity to all that whole suite of phenomena. So you've seen this graph before, thinking about sexual dimorphism and how variation in the size or composition of gonads, genital morphology, chromosomes, and or hormonal physiology, there's a significant amount of it that sits that causes this, leads to this overlap in male and female. So we have language that gives the impression that male and female is a simple binary characteristic, but because of the complexity of how male and female develops, there is variation and there is overlap. And so incomplete sexual dimorphism is the better way to be thinking about male and female categories. Now, some governments do formally recognize this diversity. So we actually saw that in the Dominican Republic, that there is a third term for this other category of children, that they're born, they look female at birth, but then when they go through puberty, they become male. So other countries recognize that you need this other category, that it's useful. So Australia, Bangladesh, Canada, Denmark, Germany, India, Malta, Nepal, New Zealand, and Pakistan. And now, actually starting in 2017, California does too. So California passed State Bill 179 in 2017. This is the Gender Recognition Act. It was signed into law in 2017 and it went into effect January 1st, 2019. And it streamlines the process for Californians to apply to change their gender markers, and creates also a non-binary gender category on California birth certificates. driver's license, identity cards, and gender change court orders. So with this in mind, I would like to offer you one more bit of demographic information just for some perspective. So if about 1 to 2% of the people around are intersex, is that common enough to merit kind of a recognition at this level? Should there be this formal recognition with a state bill? Are all these countries kind of just, blowing this out of proportion? Well, I would argue not, and I'll give you a comparison for that. 1 to 2% of the world's population has red hair. So 6% of the Scottish population, 10% of the Irish population, 4% of the population in England. So if 1 to 2% of the world's population has red hair, and we're totally fine celebrating this, we should probably be totally fine celebrating the 1 to 2% of the world's population that's intersex as well. I'll see you in the next video.